Hello and welcome to our tutorial video demonstrating the integration of Xsense wireless motion trackers with BCI 2000. In this video, we will discuss the benefits of including motion tracking in your experiment, followed by a tutorial on implementing the Xsense motion trackers with BCI 2000. BCI 2000 is an open-source, multi-purpose software tool for real-time biosignal acquisition, processing, and feedback. BCI 2000 is very adaptable and can accommodate a wide range of neurophysiological experiments, including simple stimulus presentation tasks, neurofeedback tasks, and brain-computer interface experiments. Additionally, it is very easy to add peripherals, such as the Xsense motion trackers. Why should motion be tracked in experiments? Detecting motion is a needed addition to many experiments that record a subject's physical response. For example, in a neurofeedback experiment to reduce tremor, the experimenter may want to record the amplitude of the tremor before, during, and after the task to measure the subject's performance. Using inertial monitoring units, or IMUs, the experimenter can quantitatively and accurately record the amplitude of the tremor, resulting in a more refined understanding of the subject's behavior. To start the setup, navigate to the Downloads and Documentation page of the Xsense website and find the MTW Awinda. Download the latest stable release for your operating system. This installs the needed drivers for the device. Also, the MTWs connect to the PC wirelessly using a USB signal receiver. This signal receiver must be plugged into the PC. BCI 2000 runs by executing batch files. In the batch file you are using, append log xsense mtw equals 1 next to the signal source executable. In this case, we are using signal generator. Additionally, specify number of MTWs equals X, where X is the number of MTWs you are planning on connecting to. This number must exactly match the number of MTWs that will be connected. Run the batch file to start BCI 2000. Press Set Config to connect the MTWs. Make sure the MTWs are blinking, which shows they are trying to connect. As you can see, this MTW is not blinking, which means it has fallen asleep. Wake it up by moving it around, then press Set Config again. Once the MTWs are connected, they will blink in sync with the signal receiver and with each other. Then once start is pressed and they are recording, they will blink at a quicker rate. To look at the relevant parameters, press the Config button, then navigate to the Source tab. Scroll down until you see the MTW section. For almost all cases, these parameters won't need to be changed. Master update rate is the frequency that data is sent from the MTWs to BCI 2000. The maximum rate that this can be depends on how many MTWs are connected. Here is a table of values. For example, if 4 MTWs were connected, this number could be changed to 120 Hz, but it could also be anything lower. Master radio channel chooses which radio channel the data is sent through. The default value will usually be satisfactory, but here are the frequency ranges of channels 11 through 25 in case you would like to change the value. And lastly, the data prescaler is a value that is used to convert the MTW data to degrees post-experiment. The default value is 10 million. There shouldn't be any reason to change this number. Setting it as 1 would make BCI 2000 record the data in degrees, however the precision of the data would only be to the nearest degree. Maintaining a high precision is why it is such a large number. To view the MTW data that BCI 2000 is collecting, go to View, then States and Events to see the available MTW states. Right-click on an MTW component and click Add Watch to see them in real time. You can see the BCI 2000 state change when you move the MTWs. The MTWs will be given a number ID, increasing from 1. The serial code to number pair will be printed in the BCI 2000 operator's log for ease of use, but they are also ordered from lowest serial code to highest. The serial number can also be found on the MTW. The MTWs measure rotational movement and not translational movement. Each MTW has an X, Y, and Z rotational component. The X and Z components range from -180 to 180 degrees, and the Y component ranges from -90 to 90 degrees. These MTW components will be stored as BCI 2000 states to be used for real-time feedback or evaluated after the experiment is complete. As you can see, BCI 2000 does not record the data in degrees. It does this to keep the high precision of the data. To convert the data back to degrees post-experiment, first subtract 2 to the 31st. Then divide the parameter data prescaler. This will convert the MTW data to units of degrees. You are now prepped with all the information you need to add XSense MTWs to your experiment. With a couple of simple steps, the MTWs can be implemented in any experiment in BCI 2000. If you have any lasting questions, please refer to the XSense informational page on the BCI 2000 wiki. Thank you for watching our video.